Great. Welcome to consensus layer call number 92. This is issue 574 in the PM repo. If someone can share that link on YouTube, I don't have the chat handy. Thank you. So we'll go over anything merge related. Then we'll have a segue into MEV-Boost, some current points of discussion, any other client updates, and general discussion from there. Give me 1 second and then we'll kick it off. All right, cool. Before we get into any of the particular discussion points, Perry, is there anything to share with respect to any of the shadow forks, any of the testing going on the side?
Yeah, so we had 2 shadow forks since the last call. We had a Goli shadow fork that happened last week. And one of the things, so we didn't really find any big issues. I think there was one that I don't recall right now, but it should be fixed by now. Oh yeah, the one the Nethermind team, I think, wrote a big post about in Ether&D. Yeah, but besides that, we've been testing MEV-Boost on Goli Shadow Fork 5. It looks good so far. We started with about 8% of the network, and I think now we're at about 30% of the network. I looked at reorgs, I looked at late blocks, stuff like that. Everything looks normal from my side, but in case someone notices something or has an idea on what else we need to look at, then please do let us know. We had mainnet shadow fork yesterday that merged on Tuesday, and there weren't any outright client compatibility issues, so that's great. I think it's the first time we didn't have any problems. But now that it's been a few days, I think a few of the Aragon nodes have lost peers / are failing to find blocks, but that's part of the Aragon doesn't really like the shadow forks. And I had to resync a couple of the Bezu nodes because they were on an older version. And I think they're still not up to head yet. But in general, the network's looking good. We have healthy proposals otherwise, and we're good to go. We would be having a Curly Shadow Fork 6 next week. And the idea for that one is to have MEV-Boost enabled before the transition, so we can also test how the transition would look with it enabled.
Perry, for the MEV-Boost testing, which clients are you testing in right now?
I'm just going by the Flashbots chart, so it should be Prism as well as Lodestar and Teku, I think.
Okay, thank you.
So those are the 3 that are listed as, yeah, those are the 3 that are listed as finished. I think Lighthouse as well as Nimbus are both still PRs.
Can you share that chart in the chat?
Yeah, of course.
Cool. Any other questions for Perry or general comments around shadow forks or testing? Awesome. Great work on the last one. Okay, the next agenda item is the execution layer behavior around terminal blocks. This has been a bit of a conversation over the past week on what happens, what to do around multiple valid terminal blocks, and if the consensus layer picks something that is unexpected from the execution layer, and how to handle reorgs and optimistic sync. Mikhail, can you give us a TLDR, and if there's any questions or any words of advice, make sure to pass that along.
Yeah, sure. Yeah, that's related to Goli Shadow Fork. Basically, the case occurred there with Nethermind in particular. Yeah, just let me give you a quick description of what has happened. So there was a terminal block A that Nethermind received via gossip. It's been imported. Yeah, this block reached terminal total difficulty. And after that, the other terminal block, let's call it terminal block B, has arrived via gossip. But Nethermind has this optimization. It does not process blocks that are not becoming the head of the chain, similar to Aragon behavior. So the Nethermind put this terminal block B into their block tree, but didn't process it. So there is no state for, there is no like post state for this block. Then the transition block built on top of terminal block B that hasn't been processed by a node has arrived via new payload method call. And what happened next is like Nethermind returns syncing because it does not have this, does not have a state to validate this transition payload. And then consensus layer has these safe slots to import optimistically thing, which protects us from fork choice poisoning. And here we get the compound effect of the two. Basically, the node got stuck because it can't import, it can't switch to this fork for 128 blocks, the default value for safe slots to import them optimistically. And that's it. So the outcome from this case is as follows. The expected TL behavior around the transition block is that whatever happens with like multiple terminal block received, once EL has received a transition block and when it has all the data required to recreate the parent state and validate this transition block, it must do so. So the fix is I think, in my opinion, and we have been in touch with Marek from Nethermind discussing this, the optimal fix would be if you receive like a transition block that is built on top of a terminal block B, like in this situation, then you have to execute terminal block B first and then execute a transition block and respond with the corresponding status, like valid or invalid, to allow CL to proceed with this branch. That's actually it, and this is what is expected basically. And I'm curious if I don't know. I guess that Go Ethereum behavior around this is that they are processing all blocks that are received from Gossip. Marius, can you confirm that?
All blocks up until a valid terminal block, and then not necessarily the children.
Yeah.
But on any branch.
Yes, and we process all the sibling blocks of the terminal block.
Yeah,
Right.
cool. So they are instantly processed upon receiving them from Gossip. Right.
I'm pretty sure.
Okay.
Yeah, that was my understanding as well.
Yeah, and I believe that Aragon has a fix for this as well. I don't know, Andrew, do you have any information about that?
Fix, sorry, regarding what, like multiple terminal blocks or what?
Yeah, like Aragon. Yeah, there was like a PR in the Discord, shared in the Discord, that actually do the execution in memory or whatever on a side fork.
Yeah, that's right. That's still somewhat experimental, and I also have to double check our logic, sort of specifically for multiple terminal POW blocks. I'll look into it.
Cool, and thank you. And I'm curious, what is the DASO behavior in this case?
I don't know off the top of my head, to be honest. I'd have to get back to you on that, exactly how we deal with conflicting blocks coming over Gossip for TTD. I think our expected behavior, though, is that we're going to not reorg unless we receive from the CL an expectation, like for choice update, that will reorg to that different TTD block.
Right. When you just in proof of work mode or in proof of stake mode, when you have short range forks, say two ancestors different, do you execute those, or do you just accept them and then only execute on the fork choice overtaking? Like, do you execute short range forks or not?
I think that we're in proof of work mode, we're going to just rely on the heaviest chain. And then from then we're not going to reorg at all until specifically we get direction from the CL. So
Gotcha.
A different block coming from Gossip we would probably reorg to that for the TTD block. But we would immediately switch back when the client consensus client directs us to.
Yeah, and it's important when you're switching back and you have like this block not yet processed. It's important to have it processed. This is like one of the ways to resolve this particular thing. Yeah. Why I'm asking is, oh yeah, Marek is here.
Hello. Yes. So I think Gary, you can have the same issue like we had. So we didn't process the block, and we return syncing. So it will be good to verify it in Bezu. Feel free to ask me if you want more details.
Yeah, so I think
definitely will do.
If you do execute these short range forks, then I think you're generally protected. But there's probably needs to be a note added to the spec that kind of all valid TTT blocks up until probably finalization should just be executed immediately, even if it is expensive. And I think that would resolve the issue here. And we also need to surface a couple of tests here. The interesting thing here was that TTD terminal block B was of less difficulty than terminal block A, and so it wasn't like by default executed. And I think we can easily put that into a test as well.
Yeah, I think one of the other considerations is that as soon as we hit TTD and Besu, we immediately disable our block propagation manager. So we probably have to be a tight race to get an alternative TTD block. We rely on a backward sync in that case to reorg back to a different TTD block.
Gary, I think we wait until the second finalized block before we disable that propagation.
Yeah, you disable probably propagation of, well, I would hope disable propagation of children of and descendants of a valid TTD block, but I think the spec says not to turn off the gossip until something's been finalized. It restricts the gossip and then it turns it off.
Terminal blocks should be gossiped till it's finalized.
Right.
Yeah. This is like important part of the transition to have the ability to switch between terminal blocks. And yeah, we will have Mario can confirm we'll have a test that reproduces the same scenario in Hive.
Yeah, and Mario,
yes, that is,
we'll get to.
Sorry.
Go on.
Yeah, that is correct. We are working on this specific test case to reproduce the gossip issue. One thing I would like to mention is it would be favorable to have the specific behavior expected in the spec. For example, how many blocks do we expect to gossip after the TTD and so on and so forth. I'm not sure it's already included, but it would be nice to have.
Yeah, Mikhail and I can work to make sure that this edge case is very clear.
Two additional things from my side that we should be careful is that in new block message we can send we are receiving total difficulty, but we can't rely on that. So please be careful when you are doing checks. And what is more, we need to reject everything after terminal blocks from proof of work chain. Otherwise, we could have problems.
Right. So all chains should be process incorporated and accepted via gossip up to valid terminal blocks, and then no children, no descendants of such valid blocks. And then after the chain has been finalized, you can stop gossip on that layer. Okay, but yeah, we'll make sure that this is abundantly clear in specs and make sure that a test gets out soon. Anything else on this? Okay, next up, exchange configuration before TTD is actually set for mainnet. There's a desire to do this to allow people to get their setups going, and probably some details to decide if we're going to do that. Paul, can you give us what's going on here?
Yeah, sure thing. So previously we talked about enabling this endpoint before the TTD is set. So the purpose that we want to do this is so that people can set up their bigger node and also their execution layer and consensus layer in a one-to-one relationship like they would before the merge. So I think all the teams have turned it on, which is awesome. However, it seems that from the EL side, it's unspecified how they should, like what the values they should put in the exchange transition configuration struct when the TTD is not announced. The consensus layer has a standard around this. We have these 2 to the 256 minus 2 to the 10 values that I believe all the consensus clients would use. So one option is for the execution clients to just use those values. And then another one is to kind of modify what we have now to send nils or nuns around. I have a slight preference for the first one. It means I don't need to change anything as a disclaimer, but it's also kind of an existing specification that exists that could be expanded, and then everyone would work with it. But once again, don't feel super strongly about how it goes.
Right, so that value was put in to our mainnet configurations for the ability to do testing and to do so without with a value that was sane. I mean, a value that was not going to accidentally trigger this on mainnet if things work their way into mainnet. So I do think it's a reasonable value to shove in there if people want to be able to do the configuration now.
Yeah, so I think it would probably mean for all the execution clients to just have this kind of one really big number that's a constant, and then instead of returning like nil, you just return that constant and check against that constant.
What was that constant again? It was 2 to the 256. Could you repeat that again?
2 to the 256 minus 2 to the 10. In that merge interop channel, I've linked it a few times also on the issue for this one. Yeah, Danny's got it too. It's a weird number.
Yeah, the history on that number is because we do use it for test vector generation. We didn't want to go over 2 to the 256 by accident by creating some blocks on top of stuff. So almost the biggest number. Okay, any other comments on this? Any desire not to do this? Okay, I'm not exactly sure if or where this number should land other than in code bases. I mean, it's in the consensus layer specs as a placeholder until the final releases, but I don't know if there's an equivalent place it should go on the execution layer.
So the problem is if we start adding it to Geth, then we will have like a big, like messages all around the place that the merge is configured at this point, and then there's like this really big number.
Yeah, I mean, it could be if not configured, use this value for exchange configuration rather than nil. I think that probably be the extent of it.
Yeah, yeah, we can do that.
Yeah, that'd be cool. We don't need it to actually be in effect. Just lie to us.
Okay. if someone from the execution layer thinks this should land in a spec or an issue or something to help coordinate, then by all means do so. But I don't know where that place would be.
Yeah, my preference not to include it in the spec.
Yeah.
Basically because it's just a like one-time functionality. I guess it's just easier to have it in code bases and have it like one time and done for.
Okay, I'm fine with that. Okay, Mikhail, you have an issue open on the consensus layer specs. I don't know if it's, I wrote clarification. I think it's an extension. Can you let us know what's going on here?
Yeah, there is a PR that extends the definition of what is an optimistic node, and a small context behind this. Yeah, suppose like, yeah, we have like currently we have an optimistic node definition as follows. A node is optimistic when its head is an optimistic block, when its head is optimistic. And the case that this PR addresses may happen due to optimistic sync, but it's not like related to optimistic head directly. So the case is as follows. Just imagine you have like a optimistic branch of optimistic blocks that justifies some checkpoint. So it has enough attestations to justify the new checkpoint, and it goes beyond the epoch boundary. So the checkpoint is actually becomes justified, and this justification comes into the block store. So the justified checkpoint is updated, is increased in the block store. But it happens like while all these blocks are optimistic, while the EL catches up with the state of these payloads, of correspondent payloads in parallel. And after the justified checkpoint in the store has bumped, it appears that a portion of blocks that actually do this justification appears to be invalid. So CL have to remove these invalid blocks from the block tree. And after that, we can get into a situation when there is no branch that realizes that there is no viable branch, viable in terms of FFG, meaning that there is no tip in the block tree that has justified checkpoint equal to what we have in the store. So, and the question is what to do in this case. So how the node should behave. First of all, yeah, like there could be different solutions. Like, for example, we can roll back the justified checkpoint. At the first glance, it seems okay, but it may lead to the surround routing. So it's potentially dangerous. And probably the right thing to do here is to keep the node optimistic and keep node like in syncing mode and wait for more blocks to come from like a valid, viable chain coming from the network, and then node stick to the this viable chain, syncs up to the head, and then gets back to normal operation. So this PR is just about like if this kind of situation happens and due to optimistic sync and invalidation of optimistic blocks, a beacon node stuck in this like position where there is no viable branches in the block tree, it should just keep being optimistic. That's what it is. The alternative opinion on that, and the alternative approach exposed by Kodos is that we should address this situation not only in optimistic case, but in all general case. Like, it doesn't matter how we get to this, but we should be beacon node should like behave correctly around this situation. I don't know, Boris want to give his opinion on that.
No, I kind of agree with you. It's just what I would like to see is some sort of standard of how we have to act. So I think currently, perhaps Adrian, if he's here, can correct me, but I think Tycho would revert back to the justified checkpoint and accept it as head so that they can continue importing blocks. I think Paul was about to set up to stay with an invalid head and being able to continue accepting blocks this way. Prism hasn't solved this issue yet. We don't really know what is the best way. And what I kind of see on both Tycho's and Lighthouse approaches is that if they reboot the node, they might be gossiping blocks that they knew they were invalid. Prism removes invalid blocks from the database, so that once we know what block is invalid, we're not gonna gossip it back. Yeah, I have no feelings. I just don't know of a good solution to this problem yet.
Yeah, great.
Yeah, like sorry, I missed the discussion right now before because my connection dropped. But can you say, like you mentioned something about having to revert a justified node? Like, do we consider justified blocks from optimistic sync actually as justified? Like before we have actually verified that the chain is correct?
Nodes generally do so to not disrupt the internal machinery too much. This is a critical failure. I mean, this is the node that was in optimistic sync and there was either an attack or a chain split. I mean,
right.
the general notion since the beginning of this is just that is a failure and likely requires manual intervention. So the question is, what do you do until somebody manually intervenes, I believe?
Right. I mean, I guess my question is it possible that a node votes with the source being an invalid?
No, a validator should not be voting on something that's optimistic. So
what Mika said about it being dangerous is not actually true.
It's also not dangerous because your slashing database could prevent you. It would be dangerous from a liveness standpoint if you potentially.
Wait, why would your slashing database prevent you? Oh, like, okay, as in you would be locked out, but you wouldn't get
being
slashed.
locked out is different than slashing yourself.
Well, yeah, okay.
There's a difference.
Well, I mean, in practice, in any situation where you're locked out, you're probably going to be part of the inactivity league.
Sure. Well, you can have an accidental sign message that isn't correlated with a lot of other people, and then you just exit.
Yeah, but if the block is justified, then that's probably not the case.
I would like not rely only on the slashing protection here. I mean, the node that got into this state, it just must not test at all.
Yeah, that's defined in the specification.
Yes, but when you're invalidating optimistic blocks, you're like, you just have no head, no viable head. That could be the case.
Yeah, I think it's just important to clarify that in this case, the justified checkpoint block is valid, like it's fully validated, but we've had a sequence of optimistic blocks that caused us to update justified checkpoint. And that sequence turned out to be invalid. So we shouldn't have updated a justified checkpoint, but we're kind of stuck because we aren't able to revert that in clients currently.
Right. So
does the justified checkpoint need to be fully valid? It can be optimistic, right?
Well, it needs to be fully valid if you're going to actually act on it. But
yeah, so it might be optimistic. In the normal case, it would be. And then this all kind of resolves itself and we're still optimistic regardless. it's the case when the justified checkpoint is valid, but we had to fall back to it because of an update to justified from a sequence of blocks that turned out to be invalid, that we wind up in this case where we might be attesting based on changes from optimistic blocks that we've since reverted, even though our head isn't optimistic.
So I would argue that it's important that you're not attesting to optimistic things, and that this is and acknowledging this is a failure case. And then the failure case, I don't know if it needs to be standardized, because the failure case is I either am stuck and I have to have user intervention. I have more sophisticated machinery and I can try to work myself out of these optimistic blocks, which by default, I think a lot of people don't want to do, but is not necessarily a bad thing to do if I'm able to actually go and revert this machinery, knowing that if I wasn't attesting, I'm not actually doing anything bad. I'm just trying to get out of that reality. But I don't know if one or the other needs to be the exact thing that we do.
The problem currently is if a node currently follows the stack, it will have the justified root as the head, so it will just revert the head back to its justified root, which was like pushed by invalid blocks. But it's not a problem. It's like a valid justified root with enough attestations to justify it. The problem is that there could be some honest blocks on top of this root as well. And yeah, if like majority starts to vote on the justified root, right, and I don't know, builds a block on top of this, so some of the honest block, a portion of honest block can be removed out. Yeah, but definitely it's like a very much edge case scenario. I know, probably I should like put more context to this PR. I mean, like the example of what can happen and what the situation that I'm trying like to describe now.
I just would say it's not so much edge case if given the fact that suppose an attacker can actually get some nodes into optimistic mode. So this is along those range of attacks that get worse once they manage to get you optimistic, because they only need 2 blocks. If they get the last block of an epoch and return as sinking, and then the next block of the epoch and turns out to be invalid, then they can just pull. They can just trigger justification of a new block. So only 2 blocks is enough to trigger this.
I don't want to get into details of how we can do this here, but it's a little bit more difficult than that with some changes.
Yeah, let's probably take the discussion into Discord and this PR.
So okay, I think Prism is going to do what Lighthouse is thinking on doing, on keeping an invalid head within for choice, and just ignoring the fact that in this situation we're importing blocks that where for choice is in an incoherent state.
Yeah, I think all of the approaches are pretty reasonable that are on the table as well. Teku's one, I don't see any problems with it. I think all of them, if all the nodes did it all at once, we'd be in a lot of trouble. But yeah, I don't see any problems with either way at the moment.
Yeah, I'm not a huge fan of trying to have an invalid head. It's very hard to reason about what the knock-on effects of that will be. But I need to take a bit of time and look at whether we can be sure to stay in optimistic mode. I think that's quite reasonable in this case. It's probably doable, because I think
my latest thinking with regards to optimistic is that the node doesn't care. It doesn't distinguish between optimistic and invalid. The only scenario it cares about is trying to avoid the invalid ones when it's choosing ahead, which it can't always do. But yeah, I've been trying to take that approach now, where invalid and optimistic are the same thing because you can't trust them. And all we do is try and fork around the invalid ones if we can.
That wouldn't work for us because we do differentiate between them. We actually remove everything that is invalid. So we're gonna have a root for head that is no longer in for choice. So we can treat that situation, that's a very special situation where our head is no longer in for choice as optimistic, but it would be something new.
Yeah, leaving the invalid ones around and just keeping it as optimistic is, I don't know if it's generally easier, but maybe it's harder if you haven't gone down that path.
It's easier on broad array, but we have another for choice implementation where it's really trivial to remove everything invalid. You just remove one node in a tree and automatically removes the whole subtree. But now we're getting technical.
Okay. Let's circle back in Discord in this issue and refine it. Thanks for the details and discussion, Mikhail. Okay. Any other merge related discussion points for today? Okay. Great. Moving on to MEV-Boost. There is an open issue around MEV-Boost during the transition. I think there's been some general agreement on the past call or two, but Alex, is there anything else to do before we merge this?
I don't think so. Let me grab a link here. Basically on the last call, we agreed that we would more or less have an embargo of using MEV-Boost through the merge transition. And when we would stop this quote embargo would be once we have finality. So this PR reflects that. And I just wanted to call it out before it gets merged in. I think a number of you have approved it on the PR. So I guess this is your final chance. Otherwise, that's what we'll move forward with.
Okay. Great. And MEV-Boost liveness discussion. Alex, looks like you have a doc and maybe some quick discussion points you can give us here, and then we can do some review outside of the call.
Sure. Let me also grab the link here. So let's see. What I'll drop in the chat is a very high-level sketch of a proposal. So the proposal wants to address a problem, and the problem is the following. There's essentially a very extreme failure case where nodes are using MEV-Boost post-merge, and what happens is there's this actor called a relay who should release the block after it's been committed to, after proposer has signed that this is the block they want to propose. And this relay could fail to release the data they need to, and suddenly there's a liveness failure on chain because the block just can't be assembled. So, you know, to be clear, we don't expect this to happen, but in the event that it does, we should maybe have some mitigation. What this would look like on chain is suddenly a bunch of slots are missed. And so this proposal says, why don't we just use this as a circuit breaker condition? So if there's, say, like 5 blocks in a row that are missing, nodes locally stop using MEV-Boost. This might be, you know, this could lead to a lot of false positives because there's a lot of reasons there could not be blocks suddenly, but it's sort of like a safety thing where it's like, we should at least do this and maybe do some other things as to figure out why there's suddenly no blocks. But yeah, so I wanted to bring this point up. There's this document here. The document, if you review it, it's like, again, I think pretty simple and straightforward. And part of that reasoning is because Ideally, this is something implemented in beacon nodes before the merge even happens, so pretty soon. There's a bigger conversation around how sophisticated these heuristics should be around when we, stop using MEV-Boost or when we re-enable it and things like that. And yeah, maybe you're welcome to leave comments on the doc, or maybe actually taking them to the Discord at this point would be a good place to continue.
Right. So it's easy to say you produce a block and you commit to produce to some bid and then you don't get the full block. It's easy to know locally, okay, well, I shouldn't use that relay anymore, but I also might be one validator and might not get another validator and might get another proposal for quite a while. And so that information isn't actually useful to everyone else if it's something systemic that's happening. And then there's not really a way to demonstrate that easily to your neighbors. Maybe there is with some sort of gossip and timing analysis and things like that, but we're not there. So instead, circuit breaker. That makes sense.
Mikhail, I think you raised your hand.
Yeah, I'm wondering if we can increase the max allowed message loss to something like, I don't know, 16 probably. And what like the how to say, what we get if we have this value too big? I mean, what downsides we can get into? Yes, for the current value, it's like pretty easy to be exploited by adversary, like, I don't know, that owns like 10% of the stake. They will just have a chance to just withhold these 5 blocks in a row, then publish them after some time when everyone have switched from MEV-Boost to local ELs. If there is any gain from, if there is any payout from this game, from this behavior.
Yeah, there probably is, because they can have MEV-Boost on hard-coded. Is Micah talking? Is someone talking?
I am not.
Oh, I heard someone talking very quietly in the background.
But would it really be like, I mean, how would that work if you release those blocks? I mean, it feels unlikely.
You don't even have to release the blocks, Donkred. You can just miss them, and everyone else turns off MEV-Boost except your nodes.
But then like you missed 5 blocks. I mean, that sounds
but you might have multiple. You might have many epochs in which you're the only one successfully getting MEV.
Wait, how long are we turning MEV-Boost off for?
The current suggested recovery condition is manual.
Oh, I see. Okay.
Or simplicity, probably. I mean, I would say 16. I would.
How about making it an exponentially increasing recovery period? Like first time you do like 16 blocks, then 32 blocks, and then 64 or something.
Yeah, I think that's reasonable. I think we're also probably we're going to be balancing simplicity. Just if we want to ship something like this, it would also, the other one is to say model your adversary and then find the number, what size adversary we're talking about and what number of blocks is it diminishingly small chance that they're going to get in a row.
Yeah, and just I think that it not necessarily you miss those slots. You may just withhold these blocks and release them later, so you will not miss the opportunity to propose and all this stuff. Not sure how this is feasible to do, but
I mean,
feasible.
One downside of this is like even with 5 blocks, this means MEV-Boost can only deliver every 5th block, and still everyone will continue using it. Like that's also something to consider here. Like that might also be an argument against increasing it further.
So we've actually implemented this in Lighthouse, or at least something similar. And generally what we were thinking is to allow whatever the conditions for not using MEV-Boost are, to be configurable by the user. And then like, I think generally maybe it'd be better not to strictly specify the exact value so that they aren't gameable, or at least like harder to game. And then we could even maybe have like diverse like defaults across clients about like, oh, is it 5 slots in one client and like 10 in another, something like that.
Yeah, I think I agree with that. I think much of it should be client implementation detail, just because like some policy might be easier to implement on one client versus the other client. But I do think like every client should like implement something just to prevent it.
I think the concern I have here is that we're adding a bunch more complexity to try and avoid a real corner case. And when we've done that in various ways in the past, you know, like doppelganger support, we've then seen bugs where it kicked in when it shouldn't have, which then caused kind of more problems. So I'd particularly be keen to keep this simple as possible. It's not so bad because you are falling back to your local EL, but I can kind of see a bunch of problems coming out just because we're trying to track a whole bunch of new stuff, or have all these conditions.
Martin?
Yeah, I disagree with Adrian, what you said about adding complexity, because what we're talking about here is basically a switch that disables the integration for MEV-Boost. And in the way I see it, everything should continue working perfectly if MEV-Boost goes offline, if all this, central things, or if all the components that are not layer 0 goes down, the platform should still continue working. So I don't think, if we think that MEV-Boost going down will cause us lots of problems, then we're in a bad place. So, and based on that reasoning, I don't mind adding complexity that may cause the MEV-Boost to start failing. If we, yeah. So I think it's a good thing if we add this circuit breaker to disable it. And I agree that we could do different choices in different clients, and we could even do some like randomization in individual nodes, so they have different levels for what the circuit breaker is at. That's it.
I generally agree. I mean, right now there's probably going to be one relay, maybe 2, and that they can take down the whole network if there's not a circuit breaker here. I do think that the circuit breaker can be simple, and I do think if we model the adversary and we pick it even 32 slots, it can be simple, and it can be, very unlikely to be hit by an attacker.
Yeah, I think that's one of the simplifications I'd quite like to see is, at the moment, there's a suggestion that we've got to count blocks even if they're not on the same chain in working out if we've missed the slot or not, which is definitely required for a small number of slots. But if we can make that big and be able to just look at the state and go, hey, I've not had a block. You look at the block roots in the state and go, yeah, we've missed 30 slots. Then I'll just stop using MEV-Boost. That would simplify implementations quite a lot because you're not having to track anything new at all.
Is it okay to not have an epoch of blocks though?
I mean, to automatically recover, probably once, and then we figure out what the hell went wrong and try to make it not happen ever again.
I mean, that's also assuming that everyone sets up MEV-Boost and isn't paying attention to it. So, like big providers probably see one block proposal go missing and start worrying a lot because they didn't get an unblinded block. They have that insight across their nodes. If you're running a lot of validators, and then there'll be a variety of home stakers that probably don't use MEV-Boost because it's just too much for them to set up.
I mean, this is my main concern.
So widely accepted.
this is my main concern with having a fixed number, especially a large number of blocks. That like I can see lots of conditions where we have quite a bad failure case, but people will continue using MEV-Boost. Like say MEV-Boost only delivers every third block. It's a possible failure case. And in this case, nobody would stop using MEV-Boost. So like,
stop using it automatically, but we would also work on figuring out
right
what is going on.
But we would be in a pretty terrible state in that case already. Like,
right, but that's also like an even more particular. I mean, there's failures that can happen, and there's a certain amount of like automatic detection that we can do, or is worth the complexity of doing.
Right. But maybe the threshold, I mean, you can also say like less than X blocks over a period of Y, and that's a much more robust conditions than 0 blocks over a period of Y.
Yeah, fair.
Are block builders in this version of MEV-Boost bonded in any way?
No, nor relays. Relays are kind of this, you assume the relay has the block and can make sure the block gets out when you're entering into negotiation with them. And this is this failure case when it's right in the middle of the negotiation, or kind of right at the end where you've committed, but they don't then release it.
The messages are signed, so we'll know who did it, but there's no like actual like crypto economic bond at risk.
Is there any?
And you can certainly do reputation around this. These messages can be demonstrated, and a certain amount of them could mean I don't use that relay anymore, but that's also a lot more complex than this circuit breaker.
Yeah, but I mean, I'm kind of agreeing with what I think the point that Martin was getting at earlier is that someone should not be able to take the chain down for however long, minutes, hours, whatever, by getting control of the relay. Like that's a pretty bad failure mode. Like even if we can't automatically recover, eventually,
this is the trade-off we're making with MEV-Boost. Like that's
right, but the discussion is, can we ensure that the trade-off isn't so bad in the extreme?
Yeah, sure.
Yeah, Adrian, your assessment of complexity on like a percentage of blocks, X out of N rather than a series of missing, is that of similar complexity?
Yeah, I mean, I think the ideal for me is anything we can get from the current state rather than having to look across forks. That saves me an awful lot of complexity from what I can kind of think initially.
Right.
Maybe I'm wrong in that, but that's kind of my first take.
The actor who has the ability to, or the participant in the system that has the ability to withhold the blinded blocks, that's the relay, right? And at the merge, the expectation is there will be very few relays. Is that correct?
Yes, there's also a problem with such a relay. If you didn't know to switch to relay B because no one's demonstrated to you that relay A is bad, then you also, the multiple relay doesn't necessarily help if that relay is maybe lying to you or something.
Is it visible to all participants in the network when a blinded block is committed to and then never revealed?
I do not believe that those are
only
gossiped, but they could be.
So at the moment, at least, only the proposer knows that the relay withheld never gave them the block. Is that correct?
Correct, without additional gossiping.
So I know we're very close to the merge, and so I'm hesitant to ask this, but how hard would it be to fix that? That feels pretty bad. Like it should be that if the relay is not revealing blinded blocks that they promised to reveal, like that should be known to the whole network as soon as possible. And so you can see, hey, the relay hasn't given up their blinded block in the last 4 blocks. I'm going to stop using the relay and fall back until a human intervenes. That way we can limit the failure to, a few blocks in a row until humans get involved. rather than having it continue on for 100 blocks or whatever.
I think it's tricky to make it really tight, meaning like only a few blocks versus say like an epoch, just because of the reasons we've been discussing. But yeah, like Chris put in the chat, there's this idea of like a relay monitor that I think at least Flashboss intends to have before the merge, which would handle these like high level, like the big failure cases that are easy to figure out.
Yeah, but I feel like we're not really solving the problem if we just say, hey, if that centralized player turns malicious because they got hacked or whatever, let's just trust this other centralized player to tell us about it, especially when they're both controlled by the same actor in the ecosystem. Like if someone does manage to compromise the keys of the people running MEV-Boost, they're probably gonna get both sets.
So the alternative then is like to have MEV-Boost like gossip some sort of fraud proof around this, which could be done, but
it's not necessarily
a lot to
fraud
build.
proof. It's more of
well, you're just saying, hey, here's a signature for this block, and you haven't seen this block.
Yeah,
No,
it's
so
not a fraud proof though, because you can't tell if maybe the proposer was just really late in giving it back.
Okay,
but
we can call it something else.
enough of them signals that it's probably fraud.
Well,
Right,
we can. There's one solution where you gossip your choice. Like basically, we create a channel for proposers to gossip their assigned block header. And you can watch that channel. And if you see several of these and you don't see a corresponding block, then you know that the relay is bad. The problem is like creating that. I think that's not realistic for the merge. I think that's too much. Like, because you'd also have to consider all the DOS possibilities and stuff.
Yeah, I would generally say that if you're thinking of a solution and it involves adding a new topic to the peer-to-peer network, then it's too hard for the merge. And I'm pretty sure all of them involve that, so it doesn't seem feasible at this point.
What does seem feasible is like just creating a service that monitors this. Like how hard is it to create a simple monitoring daemon that anyone connect to it using their validator. So like one of us could run it. It's independent from Flashbot. That doesn't seem that hard. Like it feels like a few hundred lines Python script can do it.
Well, we still need a mechanism for proposers to be able to get their.
So I don't know if it needs to be automated, Micah. Like it can be manual to like, facilitate shipping the merge. And then an obvious enhancement is to make it automated.
Well, if it's manual, then it means that the potential outage, if the relay is compromised, is hours to days, because people are not quick.
It wouldn't be days, but we also just said we're okay with like an epoch of missing blocks. So.
Yeah, I mean, I definitely appreciate the bind we're in. We've got the merge coming up very soon, and we have a centralized point of failure, and we have to decide, how long are we okay with the network being down if that centralized point of failure fails, and we have to live with that risk until such time as we have a real solution, such as bonding or at least gossiping intent.
Okay, so there's some appetite for a circuit breaker of some type. I'll figure out a place to make that more formal, and we can keep pushing that. Separately, there's like other different strategies and tactics we've been discussing around hardening MEV-Boost, so that's good as well.
Okay, cool. Alex, are you going to make you're going to refine the that doc and then share it. Is there a place where we're going to discuss this?
I suppose the block construction channel on the R&D Discord, but I'm open to anywhere.
Yeah, that's good.
Okay.
Okay, cool. Let me find my agenda. Oh, you're next up. Oh no, live discussion. Perfect. Anything else related to MEV-Boost?
Maybe just a quick call for Lighthouse and Nimbus to maybe wrap up the builder specs implementation so they can be tested in the next Golden Shadow fork along with the other clients. That would be ideal.
Yeah, so
Working on it.
our PR is actually under review right now, so getting close.
The same is true for Nimbus. We are close to merging this PR and we are planning to release shortly after.
Cool.
Thank you.
Okay, anything else on MEV-Boost? Great. Any notable client updates or happenings that you would like to share? Okay. Other research, spec, or other items to discuss today? And anything at all that people would like to say, announce, discuss, or otherwise?
We have a. Oh, I was just gonna say quickly, we have a 4844 call tomorrow at 14 UTC. If people want to follow up on progress on that, the link is in the PM repo.
Where's the appropriate place to cry about this MEV-Boost situation? Offline.
Maybe on the builder specs repo, you could write an issue about proposed bonding or other things like that. And also in the block production channel on the Discord.
Okay.
There's going to be no bonding before PBS.
Meaning any sort of bonding that you would do would, without L1 support, would need to be, it would be opt-in and some sort of extra protocol mechanism that relays decide to do.
Well,
whatever.
I mean, maybe with Chainlink or something, but it would suck.
Oh yeah, you would need like Alex said, a committee.
Like you need an availability oracle for the signed header and the main block, and that just I think it's very unrealistic. It's not gonna happen. I'm not just saying before the merge. I'm saying it's doesn't make sense to do this before PBS. Like MEV-Boost is literally our stopgap solution for that. That's how it was conceived, and I am, yeah.
Yeah, I think we can get better on reputation and more transparency around messages and a circuit breaker, but I also agree that you don't.
Yeah, I think these are great.
Yeah.
I mean, and I think that's totally possible. And I think like it's just like this doesn't have to be a monitoring service doesn't have to be decentralized. We can find solutions for that work very well. Like I don't know, like I mean, if there's something that like
at the moment,
like if you build a piece of software that any of us can run and that all the proposers can submit their blocks to, and that can like sound an alarm if like one relayer has missed several blocks, then like why is that not good enough? I think that's a pretty
I think
goes pretty far in addressing.
Yeah, I would be significantly happier with a solution like that than the current situation. I'm saying that I do think we should be focusing on building something, and that something is going to involve clients.
Yeah.
Like the clients are the ones that need to send to that.
No,
thing.
it does. Right. Okay, but the client, what the client has to do should be fairly minimal.
Sure. Yeah, I'm just saying, like I think this should be a focus. Like we should be figuring out what that solution looks like, even if it is centralized. You know, make it centralized-ish, right? So anyone can run one of these services, and you can point your proposer at n of them, and so you can broadcast out to 7 different ones run by 7 different people around the globe. And if any of them report back, you have evidence, and they can give you proofs.
I think very fortunately that a lot of this actually can be encapsulated inside of the MEV-Boost sidecar. And so it's much easier for MEV-Boost sidecar to add some sort of like experimental gossip channel to be tracking relays and reputation and that kind of stuff, or even be communicating with an external monitoring service. And it's been designed that way for a reason, right? So I don't have to go into the internals of the beacon node for everything, as long as like the beacon node knows to communicate with the sidecar as to get extra valuable blocks. And if the sidecar is not giving anything, it can go local. And so I think the complexity is very nicely carved out there to iterate and continue to build up MEV-Boost. Okay. Shall we close the meeting? Anything else?
Just one more thing. The Birdie blog post is out, so please update your notes. I think all the client teams have releases, and the Curly fork should be in the next 2 weeks.
Very exciting. Okay, thank you everyone. Very productive conversation. Talk to you all soon.
See you around.
Thank you.
Bye.
Bye.
Thank you.
Bye.